to this Telit and Flow Live webinar, how mobile core network technology is taking connectivity to the next level. I'm Amanda Flink, the head of global events here at Telit, and I will be moderating today's event. To explain this topic today, I'm pleased to be joined by two speakers. First, we have Curtis Govin, President Americas at Flow Live. Hi, Curtis. Thanks for joining us today.
Hi, Amanda. Thanks for having us. Looking forward to the conversation today.
Great. Yeah. Second, we've got Scott Ellis, the VP of Connectivity at Telit. Hey, Scott.
Good afternoon, everyone. Thanks for having me.
Just before I hand it over to Curtis to start our presentation, I have a few quick reminders. I would like to encourage our audience to interact by posting questions. We will have time to answer some of those at the end of the broadcast. Finally, we will send out a replay link to all attendees at the conclusion of the webinar today. And with that, Curtis, I'll hand it to you.
Thank you, Amanda. And once again, good morning, good afternoon to everyone. Looking forward to the conversation today. We'll start off the conversation talking about software-defined connectivity and how it speeds time to market. From a Flow Live perspective, all of our solutions are built on this concept of software-defined connectivity. And I think the best way to describe software-defined connectivity is to look at its general objectives and some of the main features. The general objective is really to make global IoT connectivity simple. So we start with abstracting telecom complexities. If you've been involved with telecom, have seen kind of behind the curtains and how the sausage is made, it's really complex when it comes to service provisioning. Then when you look at things like SS7 logs, GX, GY logs, and billing records, it can be quite complex. So we simplify that with abstracting those complexities and making it accessible for everyone using modern interfaces like REST APIs and a web interface. The other thing we have is the removing of dependency on hardware. This is important to improve cost controls, add flexibility in terms of how you deploy, and reduce the time to market for solutions. From a development perspective and architecture for the software, developing with microservices software architecture enables additional flexibility in what gets deployed and how it gets deployed. So microservices allows you to break out components that are necessary for your particular solution and deploy it in a quick manner with integration with APIs. The other thing that's critical for IoT is the automatic scaling of the solution there. IoT devices can vary in terms of how many devices you have and how much bandwidth those devices need. That can change rapidly for IoT. So scaling is really critical for software-defined connectivity. The other thing that is probably very common to you that have used any kind of software-defined solution, cloud-based solution, is the ability to easily add new functionality without any downtimes. I like to think about the Salesforce example where you get updates to Salesforce, it happens automatically, you virtually have no downtime associated with that. So that's another piece that is part of software-defined connectivity, is that you just add new functionality without impacting existing customers there. And then the last piece there is, the next piece I should say, is codeless service creation. And this makes it faster for the implementation of new services. We're in a new business in IoT, and that business is being defined every day with new products and new services that need to come to market, and they need to come to market quickly. The codeless service creation allows you to create new products and new services without any additional development. And then last, we finish up here with flexible deployment. That's incumbent on software-defined connectivity, where you're able to deploy in public cloud or private cloud or even physical data centers there. This means that you've got added flexibility there, where you can put some components all the way to the edge, like a PGW or an OCS, and put the rest of it in a cloud remotely or whatever fits best that application there. So I mentioned that our concepts, our solutions are really the heart of our solutions are built around this software-defined connectivity concept. But really, if you look across the industry at any of the modern IoT solutions, they're all built around this fundamental concepts that we've talked about here with software-defined connectivity, because it simply makes things simple for global IoT connectivity. So that's an overview of software-defined connectivity. Again, the heart of the solutions that we have at Flow Live and the heart of solutions, modern solutions for IoT. I'm going to pass it over to Scott now to talk about eSIMs and challenges in cellular connectivity.
Thanks, Curtis. Good afternoon, everyone. So one thing to start off with is when we're talking about eSIM and the rise of eSIM, it's important that we also clarify that we're not just talking about embedded SIM, but the true EUICC with full functionality, remote provisioning, et cetera. So the two terms kind of get used interchangeably in the market. So just to be clear, we're talking EUICC functionality and in addition to embedded SIM as an option, but eSIM shipments have grown exponentially as of late, being driven primarily by the launch of eSIM-enabled smartphones, a number of IoT devices, smart watches, and all of these things are really driving adoption and pushing this new technology into the forefront to the point that, the uptake has grown, increased about 83% year over year. And this is really creating a lot of new business opportunities for our industry for eSIM personalization, lifecycle management, and security services. Go ahead, next slide. So as we look at, what's driving this behavior with the end users, and by the way, about 80% of enterprises mentioned that they're going to use eSIM or have used eSIM already. And the primary attributes that they like about this technology are the diagnostic tools for troubleshooting, the ability to activate anytime, anywhere around the world with remote provisioning, and the enhanced security that's available through this technology. So these are really, as you can see, the scores, very highly rated attributes of this technology. And those are the elements that we're going to focus on and really try and promote in the marketplace. Next slide. So when you consider the challenges for cellular connectivity on global deployments, we'll learn a little bit about why eSIM has become so attractive. One of the big challenges has been scale in global deployment. Device hardware certifications and the bands that are required by country to support cellular connections vary, they vary a lot around the world. So going through the exercise of doing all of this work for regional deployments becomes very cumbersome. Lower volume and low mobility allow the traditional certifications to happen, but when we're talking about high volume global deployments, it becomes much more challenging. Distribution and logistics support costs rise. When we talk about scale, you'd think it'd be the other way, but there's a tipping point that says when we get to a certain level, it becomes even more cumbersome to do it than when it's small. And that leads to frustration with the customer or the end user, frustration with our distribution channel partners when they're trying to manage all these different requirements in each region. The resilience and reliability of the cellular connection also become a challenge as the range of the product lines increase. Traditional cellular providers can have challenges maintaining a reliable connection, providing adequate coverage. These micro regions, and when we say micro regions, we're even talking about in the inner cities or urban locations where coverage is challenged because of, buildings or whatever else, we become ever more dependent on the ability to troubleshoot and provide, some other solution beyond a single MNO. Next slide. So continuing that thought, in this category, we're looking at scaling IoT deployments on the radio access network at the edge with infrastructure designed for extreme load variations. And the challenge is if I put a whole lot of devices in a single location and I tax a single site or a few sites, how does the network respond? How can it keep up with my demand? And when I've got a cloud-based solution that I can, adjust on the fly to meet that demand, my quality of service increases exponentially. And that plays directly into that reliability on the cellular connection. Traditional providers have a major effort to increase capacity. They have to put up hardware infrastructure. They have to go out and install software at those sites. But with cloud-based solutions, we can adjust on the fly, if you will, to spikes in capacity requirement. Resources can be hot added, and we can dynamically expand the allocation of resources with software-based solutions. And so that's leading us to the next topic, which is multi-IMSI options that allow us to adjust on the fly. And for that, I'll turn it back over to Curtis.
Great, thank you, Seth. Clear from your examples that the software-defined connectivity is meeting those challenges that we talked about there. But now, as we look at kind of multi-IMSI, before we dive into that, there are other solutions and other methods there that come with their own benefits and challenges. So I wanted to take a look at those first to kind of set the context there. Of course, eSIM is a part of that, but if we kind of go back to traditional IoT, multiple local SIMs, I'll look at this slide really in the context of, who you're getting the solution from and what you're getting. So the multiple local SIMs there, you get that from multiple operators, as it suggests, and you're getting a single profile from each of those operators. Some of the challenges that come along with that in the traditional way and that led to multi-IMSI and EUICC is the first one is you have an operator lock-in. You deploy that SIM, that is the SIM that you have for the life of that device unless you go and physically change that SIM out of your device, even if that's applicable. In some cases, devices that are hermetically sealed, for example, you can't change the SIM without destroying the device. So that operator lock-in is one of the chief challenges. But the other kind of bigger category that I would say is complexity. You have multiple contracts that you have to sign with each operator. Every operator has their own platform. You do a network integration with them. And then from a logistics perspective, you've got multiple SIM SKUs to deal with. So this is kind of the legacy problem of IoT, global IoT, or even deploying in a diverse country where you have multiple MNOs that are tier ones and you need coverage across many of them. The next one was, a bit of an improvement on that, where you have a global roaming SIM. You could either get that from a single operator, but more than likely you were getting the global SIM, roaming SIM from a mobile virtual network operator. It had, like the previous example, had a single profile, but it had the benefit of you had that one SKU that you could deploy around the world and simplify the logistics there. You also had one integration from a network perspective and one platform. So great improvement from going from multiple local SIMs to add that. However, it too comes with its challenges. The number one, I would say, would be performance. If you have a solution that is latency dependent, whether that's a battery-based device that needs low latency to save battery, or you have some solution that maybe has voice over IP as an example where latency is a concern. That performance, when it comes to a roaming SIM, becomes a problem. And that is fundamentally because the data always travels back to a home country. So that also brings into the question of data privacy, GDPR, which has come into the picture in the recent years. For example, if you're using a roaming SIM in Europe, GDPR comes into play there. And then the last thing is the permanent roaming regulations that come into play. And this is regulatory bodies around the world protecting kind of the home territory, if you will, preventing devices from permanently roaming in. So if you had that roaming SIM, you might lose service if you had to be in a country longer than 30 to 60 days there. Operator profiles is really a subset of what you were getting from the previous two examples. And then as Scott mentioned earlier, EUIC comes into play. Who do you get the EUICC from? You get that from multiple operators if you're doing it on your own. Or you could get an EUICC from one MVNO. They've kind of done the legwork ahead of you and groundwork and worked on the multiple integrations with multiple operators there. So MVNO option actually, I think is the most preferred option unless you want to go through the previous multiple local SIM solution where you're dealing with multiple operators and multiple integrations there. What you get an EUIC SIM profile, which is simply everything you need on the SIM for that SIM to connect to an operator's network and function there. Benefits, again, very much like the roaming scenario, you only have one SIM that can be deployed and updated remotely in the field. That was the new piece that was added with EUICC. It still comes with the challenges of multiple integrations. In fact, I would say it gets a little bit more complex if you look at doing it with multiple operators versus doing it with the MVNO, because there's back-end infrastructure that's new for EUICC that needs to be integrated with each MNO's infrastructure there as well. The other thing that's come into play, and I think this is maybe a more recent case there, is you still have an operator lock-in in some cases. And it's not the traditional lock-in where it's locked in from the time you buy the SIM, but some operators actually require that once you use their EUICC profile, you're not able to switch from that profile. So that becomes a challenge there. And then in addition to that, you have higher cost associated with it. The physical SIM itself comes at a higher cost. And then there are other components like the SMSR that you would have to host if you're doing it on your own. If you're doing it with an MVNO, the MVNO takes care of that for you. And then you also have transaction fees that come along with each download, right? So, all of these particular applications, they have an area where they're the best fit. Kind of as we transition here to the next slide and look at the multi-IMSI approach, we see some of those issues getting resolved with multiple multi-IMSI, I should say. So what is the multi-IMSI approach? Really, there are two variations in terms of what you get in the SIM. The first would be very much like the EUICC, where there's a profile that gets added to the SIM. That profile is connected to the operator's core network fully. The other option is where you get what we would call an IMSI, and an MVNO would have their own core network infrastructure where that SIM profile would be built and hosted there. Gives you a lot more flexibility. That's actually what we support at Flow Live, and I know our friends at Telit support that method as well. So how does it work? It's an applet on the SIM, which is basically software on the SIM that allows you to do the functions of adding, editing, and removing IMSIs, either directly or you could do that out in the field, just like you could with EUICC. Another component that's added here that's a benefit is the ability to add additional functionality like autonomous switching between the different profiles. As an example, if you lose coverage with one profile, the applet can dictate which profile, how long it will wait for you to lose that coverage and not recover. And then it also dictate what other profiles to try. So that's a great benefit there. I call it kind of the orchestration of the different IMSIs. You have that right on the SIM versus doing that remotely. Number of benefits as well to multi-IMSI there. Obviously adding new operators remotely in the field. You have cost controls built in as well. Because you're not locked into a particular operator, if you're balancing costs between different operators, you can do that. But you also have the cost controls that are associated with savings from the different interfaces that I mentioned earlier. The other thing I would note, that the greatest benefit is the coverage, the enhanced coverage. Long been said in the industry that coverage is king. So the ability to have redundant coverage within a single SIM there, either in country or an expanded coverage globally, that's a tremendous benefit. The other thing I would mention is that's very important to enterprise is who controls the SIM. This is a case because you don't have an operator lock-in. The enterprise is able to control the SIMs through the interfaces that MVNOs and others would give them access to. Another advantage, if you look at it compared to EUICC, lower cost. The SIM itself, you're using a standard EUICC, whether that's a physical plastic SIM or an embedded SIM. That SIM cost is cheaper. You also remove the OTA transaction fees for downloading profiles that you have with EUICC. And then you have a single back-end integration versus multiple that you would have with an EUICC solution. So ultimately, you remove these pieces there and you end up with faster time to market overall. That's a cover there of the multi-IMSI there. With that, if we go into the next slide here, we'll take a look at the back-end infrastructure that's supporting the SIM connectivity. In particular, let's look at cloud native core networks and how they are essential for IoT. If you look at traditional mobile networks, they were built on a vendor-specific hardware. So one vendor made the core network infrastructure that ran only on their hardware, and that hardware was deployed in physical data centers, right? This is how mobile networks have traditionally worked, and many of them still work in the same way. These networks, it's also important to note that these networks were obviously built to support consumer and enterprise mobile phones. So IoT was an add-on there, an extension of using that existing network infrastructure. But as we well know, the growth of IoT and the expanding number of applications and use cases, it demands more flexibility from the core network infrastructure. So what we're seeing the trend to now is that operators and MVNOs are deploying core networks that are dedicated specifically for IoT. And that gives them the numerous use cases requiring the flexibility. You now have that flexibility. And the piece that you would normally have that would be a barrier, where the consumer devices make up 80 to 90% of the operator's current revenue, and you would not be able to touch that environment, is absolutely forbidden. Now you have a network infrastructure that's dedicated that you can actually go and do specific things for IoT. The other piece that's important to note is that the cost of the consumer core network, because it was that dedicated infrastructure deployed as it was really high. In fact, it's prohibitive for many of the low ARPU IoT solutions that we're seeing, particularly LPWAN type solutions where you have devices that are going to be discarded in months, solutions that only use a very, very limited data per year. Those are, to put those solutions on traditional hardware is really cost prohibitive. And then the other thing that you have with a dedicated core network there is the fact that you've removed some of that risk to the consumer business. Note I say you remove some of it because you haven't removed all of it. You're still connected to the same radio access network. There's the chance, as Scott had mentioned earlier, that you could have a surge of activity and those devices now will cause congestion on the radio access part of the network, but it actually removes the core components there. The other piece that we have there is the elastic scaling. Another thing that you mentioned, when you have that surge of activity, which is erratic for IoT devices because they're event-based. You don't know how many devices are going to show up at a shipyard that all need to connect at one time, other devices that need to have firmware updates as well. That can be cause the need for, the surge in usage there. So you need that elastic scaling piece there. And then, the other piece there is critical is the lower total cost of ownership for the solution there. And having an IoT specific core network allows the operators to start with something that's smaller and grow as the IoT needs grow. So they're not building the bandwidth into their existing infrastructure. They have separate dedicated bandwidth that they can scale as their business grows or as an MVNO business grows. So that brings us to, the need not only for an IoT specific core network, but a cloud native core network as well. So as we go to the next slide here, you'll see in the cloud native piece, the first thing that's addressed there is the elastic scaling. When you're deploying in the cloud environment, this allows for that surge of usage, surge of devices there, because the infrastructure is built in clusters, so you can borrow the necessary resources from the that are available there to handle that surge there. Cloud environments also are seamless for introduction of new functionality and features that we mentioned earlier, in the Salesforce example, without the need for service disruption. And then you're also the architecture there, the software architecture built on microservices there. You can deploy individual pieces. And you'll see this as we kind of look a little bit into the services that we provide at FlowLive and how we could separate the individual components based on what's needed for a particular enterprise. The other thing that is clear as well is that you can deploy a high performing network. Networks that are not only built for the higher capacity, but because you're able to deploy them closer to the edge and then closer to the environment. In our case, we have a globally distributed core network. So within country, they're closer there. So you can increase the performance of the network overall versus a roaming situation example. And then lastly there, the zero CapEx there, the ability to start small. Many of the cases here, you're seeing core network as a service. So that's fully managed and sold as a pay-per-use solution there, which means that as an enterprise, you start small, you're paying what you're using versus paying for something that's built beyond the scale that you need there. So, just kind of summarizing this as we go on, and we'll take a look at the FlowLive solution stack there. The core network are really the future of the technology here. Because of the flexibility, the cost model fits better, and you're able to increase performance overall. So now we'll take a look at the FlowLive solution stack here, and where you'll see, a lot of what we discussed already, you'll see that in action with the FlowLive solution stack. So Flow Control, that is our holistic private IoT platform. It supports all of the 3GPP technologies, including LPWAN, and very soon to roll out with 5G. It's also a low total cost of ownership solution there that's offered as a fully managed solution, as I mentioned just a minute ago. FlowNet is our global connectivity service. That includes a global IMSI library. So the multi-IMSI solution that has all of the IMSIs available on one SIM. It's also supported by a globally distributed core network to increase that performance, to solve things like data privacy, et cetera. And the key thing here with this functionality is it localizes the connectivity so that when devices connect, they're always connecting in the same simple and secure manner anywhere in the world. That consistency, when we talk about network resiliency, when we talk about the consistency of service there, This is a key component that's delivered to there. In addition, with multiple core networks around the world, we talk about the performance there. You're able to ensure that you have the best performance in terms of high throughput, low latency, and also when you have that local core network within country, it also solves the issue of data privacy there. GDPR and roaming regulations are resolved with that infrastructure being within country. Right? As we go to the next slide, please. Now, our architecture is built on a common framework. As I mentioned earlier, you'll see a lot of the things that we talked about throughout in terms of the infrastructure being agnostic, being able to deploy it on public, private, or physical data centers, using things like virtual machines, virtual network functions, Kubernetes there, gives us flexibility. Decoupling of services because they're microservices. Everything that you see kind of above the line, the different components there can be sold as individual pieces because they're built as individual pieces that work seamlessly together, but they can be removed and connected with other systems as needed there. And then the high performance when you're having the cloud resources in memory grid, that allows you to dynamically use and expand the resources you have. Elastic scaling, the geo redundancy that comes when you can deploy a solution on-prem, part of it, the other part you can deploy in the cloud or any other way. Flow Connect is our connectivity management platform. Floor Core that we'll talk about a little bit more detail there is our full stack 3GPP core network. Flow BSS is our full telco grade BSS solution. Flow SIM includes our multi-IMSI solution that we've talked about in the past. So all of the functionality is built in there for our IMSI library. And then a new solution that we're bringing to market this quarter is device management through Flow Device there. So if we'll finish up on the next slide with our Flow Core. And just quickly talk about the fact that we own and built from the ground up, we own the IP, a full stack 3GPP core network, including 5G. So we own every piece but the RAN, but we partner with RAN providers to provide a fully private RAN if necessary, so that you could have the full stack available. It's cloud native there. And, you know, as we've talked about before, that makes it geared for high performance there in terms of design and implementation and how we deploy. We also have advanced technology like cups where we can separate the control plane and user plane and even get more granular in terms of how we're directing the data toward the closest point to improve performance there. It's also can be distributed close to a device or an application to meet those higher throughput, latency and resiliency requirements there. So we ended here in our overview with Flow Core because this is a solution for which we partner with our friends here at Telit. So let's transition to Scott to give us an overview of the Telit solution stack.
Thanks, Curtis. Great info there. Appreciate it. So just a little bit about Telit and how we're approaching the space. Telit's got about 20 years, a little more than 20 years experience in the machine-to-machine, we used to call it, but IoT space now. And we're definitely a leading enabler of the Internet of Things. Our modules, connectivity platform and services enable end-to-end IoT deployments from things to apps. You can use our modules, connectivity and platforms separately or bundle everything together as an integrated end-to-end solution, which really reduces risk and complexity and time to market versus trying to engineer everything yourself. So we're really trying to do a good job of offering a full stack of as much of the solution for connectivity and device management and device access as possible. The edge hardware is really the foundation of a digital first and absolutely connected solution. So if we start on the left-hand side of the slide, and go to the right, all streamlining from the left, pays huge dividends later on. So when we integrate the connectivity solution into the module, which is integrated into device, then you can further integrate into platforms and do a lot of things with analytics on the health of the network connection, how the device is performing, not only for the application, but as a cellular connected device, connecting, disconnecting, etc. So the next step in this process really was to go to the eSIM or iSIM type solution, and that's what we're going to explore next. So the Telit connectivity offering was traditionally one that we're familiar with as a group, right? We aggregated together several network providers. Curtis talked about it earlier, giving you that single point of interface, a single platform to manage multiple network options. Didn't matter which technology we're on, whether that was 2G, 3G, 4G, or even 5G coming up. Doesn't matter which carrier you're on. We've got a single set of APIs and a single set of rules that can be used to manage your deployment regardless of where it is in the world. And so, taking that to the next level, we start to look at, again, this eSIM, EUICC technology. And, through all of those offerings, we currently have access to over 600 mobile operators in about 190 countries. And 5G is not quite here yet, but it will be very soon. So go ahead, next slide. When we look at the SIM technologies that have been in play in this space, of course, over the course of 20 years, we've pretty much seen them all. Standard insertable eSIM, which started out as really just a solder down component to be integrated into the hardware element. But now with EUICC, we're able to take that a step further. And as we discussed earlier, have some remote control, some remote ability to provision for the first time, depending on where it is, set some rules, etc. So, really excited about it. And it's not just an embedded form factor. It can come in any of the traditional form factors as well. The embedded just seems to be the most convenient. The next step in that is the wafer level embedded chip design, which you can see there. It says Telit SIM chip beside the matchstick. It's this really miniaturized version. And then the final step would be IUICC or iSIM, which we are capable of today. We're just looking for partnerships with around the world. We do have one working solution in Europe, but that's really where we see things going beyond EUICC. But for today, we can go to the next slide and talk about how the integration of an EUICC compliant solution in our new partnership with FlowLive has enabled us to launch what we're calling the Telit Next network. So continuing on our single point of interface, single access point, single set of rules to manage your connections, we're making available not only an EUICC compliant embedded SIM, but also insertable that really has provided a lot more flexibility and given us more choices for our enterprise customer solutions. For mission critical customer service, it really makes it a more robust, more globally scalable solution that the marketplace is demanding. And so summarizing that offering on the next slide, we see, again, 600 operators over 190 countries, soon to be 5G, full geo redundancy with both on-prem installation as well as in the AWS cloud, offering increased reliability. The security elements that are available are extremely enhanced. So we can do VPN, private APN. You can set up access control for designated IPs. You can set network-based security rules and alerts and triggers that will show, if a device IMEI has been changed or if a device is having trouble connecting for any reason, there's just a lot more information available about the health of your device's ability to connect to the network and give you some more control there. And then again, that single management platform really allows you to act in a way that is proactive for controlling the health of your deployment instead of reactive, because as we go global and we put devices in a number of different network operator situations, a number of different technologies around the world, it's not so much if you're going to have a challenge, but when, and troubleshooting is going to be required. Information is paramount at that point, and being able to really dig in and see exactly how the device is behaving, connecting, and the history of that is critical for troubleshooting and resolving these things in a timely manner. So on the next slide, we'll have a look at the basic network architecture for this solution that we've put together with FlowLive. We're connecting our things on the left-hand side of the slide through our eSIM technology. Again, not worrying about which type of access we have, because we normalize that into a single view for all of our partners. And then we bring it into the back-end service there where we've partnered with FlowLive. Sorry, next slide. For the HSS and the HLR, and deliver that out to our management application platform, which gives us the ability to run all those smart things, figure out locations, do diagnostics, all that fun stuff that we talked about earlier. So with that, I think I'm going to wrap up my overview, and we'll have just a few minutes left for some questions. So Amanda, do we have...
Yeah, we sure do. And let's just dive right in, because I know we are headed to the top of the hour here. Got quite a few questions that came in. First one I see here: does multi-IMSI approach have any impact on the power usage of the device? And if so, how much is it? And Scott, that may be a question for you.
I'm sorry, Brooke, could you say it again?
Sure. Does multi-IMSI approach have any impact on the power usage of the device?
Oh, sure. It'd be very little, right? The power consumption is really going to be driven by the device's connection behavior on the network. So you might have a little bit of extra usage as you have trouble connecting and make a change, but intelligence can be built in so that happens very quickly. So it's really going to have minimal impact if the logic's built right, which is what we're here to help you do. So I think the answer is a good no, but with the caveat that as long as it's applied smartly, which we can do.
Great, thanks, Scott. Next question here. Under the multi-IMSI model, what is the difference between operator providing a profile versus real IMSI? Won't FlowLive get an IMSI in either case?
Yeah. So the profile itself is the case where all of the information security keys are built into the SIM, but it's really connecting back to the MNO's core network, in particular their HSS and their PGWs. In the IMSI case, it would be registering on a FlowLive, HSS, PGW, or a Telit network infrastructure as well. So that's the fundamental difference, which gives you more control and autonomy in that case.
Great, thanks, Curtis. This one may also be for you. I'm building devices to enable customers to monitor their assets. Am I the enterprise customer or is my customer the enterprise customer who can control the SIM?
Yeah, I think it's kind of go back to the top. You're obviously his customer is his customer. He would be a customer to FlowLive or to Telit. So he would be seen as he or she, I should say, would be seen as the enterprise customer for us.
Great, thank you. Next question, possibly for Scott. What are the mistakes you see IoT connectivity customers making when they select a provider?
So I think the biggest one is not asking all the right questions, which is difficult if you don't know what all the right questions to ask are. So, doing your due diligence and thinking long-term about, not just this year, but the next several years in managing my deployment. Over the life cycle of these devices that are out in the field, the biggest no is to go out and touch them, right? It's very costly to visit or recall a product to make a change. So having the ability to troubleshoot and make changes and update over the air and ensuring that your partner has the ability to do that is really critically important. So, I think one of the challenges there is we get caught up in this cost is king. I have to have the least expensive option, and the least expensive option is not always the best solution. It just depends on your situation. So I would say, do your due diligence, talk to different providers, and make sure you really think long-term about, in 5 years, where am I going to be and what are my needs going to be? The network's going to change. So do you have the ability to change with it?
Great, thanks, Scott. And thanks to you, Curtis, as well. I know that we're coming up on the hour here, so I believe that's all the time we've got for today. Audience, please be sure to check your inboxes in the coming days. We will send out that replay link. Thank you again, Curtis, Scott, for a great discussion today, and thanks to all who joined us.
Thank you, and thanks for all for joining.
Have a great day.
Thanks.